on the bottom of page 621, we're going to prove tan squared theta plus 1 equals secant squared theta. But you will never be asked this on a test, because if you look on your formula sheet, the third formula is that tan squared theta plus 1 equals secant squared theta. So if they ask you this on the exam, all you would have to do is go to your formula sheet and say, this is secant squared theta, I'm done. Because I'm allowed to use any identity on my formula sheet. But what we're going to do right now is we're going to assume we don't have that on our formula sheet, and we're just allowed to use the things that we had up till now. Now, up till now, all we have is the ways to change things to sine and cosine, and we have our big idea that sine squared theta plus cos squared theta equals 1. So if I went to this question and I used the strategy of changing things to sine and cosine, can you see that you could change tan theta to sine theta over cos theta? So tan squared theta will be sine squared theta over cos squared theta. And secant squared theta, well, if secant is 1 over cos theta, then secant squared theta is 1 over cos squared theta. So that's the first thing that you might have run into from questions 1 to 24. But now it's formal. How do you deal with squareds? Well, if you have tan squared, it's just sine squared theta over cos squared theta. Now, what's our main strategy? Get a single fraction on both sides. Question?
If you do 3 over 2, then you don't get 5 more. Well, if you do 3 squared over 2 squared, you get 2 over 2.
But there's no numbers here.
Yeah, but if you're applying the same measure.
If you have 3 over 2, right? But it doesn't change to sine and cos. 3 over 2 can't change to anything but 3 over 2. So
Oh, okay.
right? Okay. So now I'm going to get a
Mr.
single fraction
Wachenko,
on
please
both
buzz your
sides.
location. Mr. Wachenko, please buzz your location.
So how do I get a common fraction? Well, I have to add things together. That'll give me a common fraction of cos squared theta. And on the top, I add the tops together. I'd have sine squared theta plus cos squared theta. And almost all the proofs we've done up till now, if you got a single fraction and you simplified, it worked. But now I have a single fraction on both sides. I can't cancel anything out, but they're not quite the same. But do you see how close they are? Can you see that if you use the big idea that sine squared theta plus cos squared theta is equal to 1, then I can change the left side now. I'm allowed to do that because it's on my formula sheet and it's our big idea. Then I get 1 over cos squared theta. And the left side's equal to the right side. And I prove. Now this result is so useful and so important that they've added it to your formula sheet. That tan squared theta plus 1 equals secant squared theta, which means anytime you have a tan squared theta plus 1 in a proof, you can immediately change it to a secant squared theta. Similarly, they've included the other proof, which we're not going to do. We could do it the same way. That 1 plus cotangent squared theta is cosecant squared theta. These are called your Pythagorean identities, along with sine squared theta plus cos squared theta equals 1.
Sorry, I was just looking to see the student was there. And if the student was there, that I was going to ask. I moved my undergarment. I'm going to start. But when I looked around, I didn't see the student, so I'm like, okay, the student's not there. And then by that point, it was too late. I'm so sorry. Yeah, I'm so sorry. Brian.
I looked at attendance here. That's okay. That's okay. This is good. This is good.
Oh, I mean, you're welcome.
Yes. This is very
I
good.
did that on purpose.
Pythagorean identities. And these Pythagorean identities, you know we've done this lots already, right? That sine squared theta is 1 minus cos squared theta. And that cos squared theta is 1 minus sine squared theta. In a proof, any rearrangement that you can get by doing only one mental math manipulation is perfectly fine. So in a proof, if you have a sine squared theta and you want to change it to 1 minus cos squared theta, you can. Or if you have a 1 minus sine squared theta, you can immediately change it to cos squared theta without showing any work, even though the formula isn't that form on your formula sheet. Okay? Where it gets dangerous is sometimes I see students, this wouldn't be allowed. I see sometimes a question that has a negative cosecant squared theta, okay? I can't write it in red, it's not wrong, I'll write it in green, but it's not allowed without showing work. Okay. I took this one. Can you see that that's true? Mental math-wise, what did I do? I moved the cosecant squared to the left, and I moved the cotangent squared to the right. But I did two mental math things to do that. So on a proof, they're not going to like that because you didn't show work. You would have to show one step in between. I totally agree that all of you can do that in your head, what I just did. Pretty sure most of us can do two mental math things. But the danger is where do you stop? So I can do 3 mental math things. I can do 5 mental math things. I can get to a proof and I can just say, yeah, it works. I'm perfectly fine. Right? So we get to a question like number 1 here. And be like, yeah, it works. Cosecant theta, I'm done. Can you please give me full marks? No. So if you can use a formula that does one mental math thing, perfectly fine. But if you start to do more than one mental math thing, then we run into a problem. Okay? All right, did I make this? Let's see. There we go. Off to the side here. Do I have it set up? Oh, I do. So nice. I'm just going to erase E for now. So step 1 is you have to rewrite things. I'm being lazy. I'm not rewriting it. On a test, you don't have to rewrite it because you can just draw the line right away. We split up both sides. And I have cotangent theta plus tangent theta equals cosecant theta secant theta. Now, I might be tempted on the left side to put everything with tangent, because that would make it all one thing. But on the right-hand side, can I make those with tangent? No. So the main strategy is going to be the best one in this case. The main strategy, I'm going to change cotangent to cos theta over sine theta. I'm going to change tangent to sine theta over cos theta. And over here, I'm going to change cosecant to 1 over sine theta and secant to 1 over cos theta. It is a must that you have those memorized and able to use quickly, because we do it so much where we change from one to the other. So you have to know that cosecant is 1 over sine theta, secant is 1 over cos theta, cotangent is cos theta over sine theta, and tangent theta is sine theta over cos theta. Then our main strategy after changing to sine theta and cos theta is, can you get a single fraction on both sides? The right-hand side, how do you do a fraction times a fraction? Well, you multiply the tops. 1 times 1 would be 1. Sine theta times cos theta would be sine theta cos theta. On the left-hand side, how do you add fractions? I need a common denominator. So can you see that this one's missing a cos theta? So we multiply top and bottom by cos theta. And this one's missing a sine theta. So we multiply top and bottom by sine theta. There's not a lot of room. You might be tempted not to write the theta. If you don't write the theta, I have to take off an E3 error. But now you see that you have a common denominator of cos theta sine theta. And so I can add the tops, and cos theta times cos theta, that's cos squared theta. And sine theta times sine theta, that's sine squared theta. And so we have a single fraction on both sides. But they're not the same. So then you have to start looking, are there any of my Pythagorean identities that I could use? And some of you see it. I have my sine squared theta and cos squared theta on the top there. I'm allowed to just change that to 1. Now my left side equals my right side. Nice. Part B. Acute. Right? If questions with squares are harder, questions with cubes must be even harder. Possibly. Okay. But in this example, it's actually not going to be bad at all. But it will be bad if you decide to just use the main strategy. If you change things to sine theta and cos theta, it's a very long and algebraically painful proof. But if you notice, this side's in cotangent theta. This side has a lot of cotangent thetas. If only there was a way to change the cosecant squared theta to cotangent, that would make everything with cotangent. And if you can make everything with one trig function, that's usually going to be a shortcut for a proof. Now you have to have these formulas memorized for AP Calculus. They're on your formula sheet. But I'm going to tell you, you need to have them mostly memorized for proofs anyways. Because if you do not see that cosecant squared theta is related to cotangent squared theta via that identity, you're going to make this very hard to do. So having your identities memorized, and this next step I'm going to say, I can substitute in for that cosecant squared, I can write it as cotangent squared theta plus 1. Now both sides of my proof are with cotangent. Oh. Whoever's eraser that was, I thought it was a mouse. It scared me just a little bit. You can pick it up, it's not a mouse. It's right by your desk. And then it is, there we go. Okay, so now what can we do? Well, we have some algebra. You're allowed to distribute, right? You can do all of your algebra stuff. If I distribute, I get cotangent cubed plus cotangent theta minus cotangent theta. Oh, it's starting to look really good. Cotangent cubed. We are done. Okay. Mm. So if we can get both sides to the same trig function, that makes our life easier. Questions you can do after this one. Ooh, I have one more. Do I have it here? Yeah, okay, we're gonna do one more, I'm gonna add one more. I'm going to also take this part out. Because I'm going to introduce to you another strategy. This one too, if you decided to use the main strategy of changing to sine and cosine, it's going to cause you a headache. But I look at my Pythagorean identities and I'm kind of like, there's a relationship between tan and secant. Tan squared theta plus 1 is secant squared theta. So I could change a tan squared or I could change a secant squared on the right-hand side. But what do I do with those 4s? Because the formula doesn't have a 4 in it. Okay? In proofs, this strategy or this thing comes up a fair bit. Do you remember factoring differences of squares in grade 10? Like x squared minus 9 was x plus 3, x minus 3. That's a difference of squares. The left side is a difference of squares. It's something squared minus something squared. So I can factor it. If I factor it, I would get tan squared theta, tan squared theta plus secant squared theta, and tan squared theta minus secant squared theta. I'm going to lose a mark in my next step, so don't write it down. But my next step won't be wrong. But I'm going to lose a mark. I'm going to lose a mark because of this. But it's not wrong. Can you see why it's right? Can you see why I'm allowed to, well, technically not allowed, but I am allowed that tan squared theta minus secant squared theta is negative 1.
You didn't show your work.
I didn't show my work.
So I lose a mark.
That's why I lose a mark. Because I didn't show my work. But can you see that taking this, I can do two mental math things to that second equation. I can move the secant squared over, and I can move the 1 over. And I would get that tan squared theta minus secant squared theta is minus 1. Okay? Now the reason I wanted you to see that is because it gives you, seeing that tells you should work with this. I shouldn't work with tan squared plus secant squared. Can you do any mental math manipulations to that to ever get tan squared plus secant squared by itself on one side? No. You would always have a minus with the secant squared. So what we have to be able to do is we have to realize that this is the one that we can work with. Okay? So what I'm going to do is I'm going to say, well, I could replace the secant squared with tan squared theta plus 1. And then I can do that. Because tan squared minus tan squared, that'll be 0. And then negative gets distributed to the 1 will be negative 1. So if I show that extra step, then it's fine. But sometimes you're going to do a lot of mental math to realize what you can work with. So to the realization that we are able to work with this and change it, but this actually isn't helpful to change. If I now distribute my negative, I'm going to get negative tan squared theta minus secant squared theta. Is that identical to the other side? Yes. We're starting to get into proofs where the main strategy that we've learned up till now isn't necessarily always the best strategy. The main strategy will work eventually, but in this one particular, the sine to the 4, cos to the 4 will not work out nicely for you. So we start some new strategies. New strategy so far, this one, difference of squares. Did I give you questions already for this one? 3, 5. In 6 and 7, the I part is the prove part. I just want you to prove them. Probably the I part is verify. Verify is annoying. Because once you've proven something, you never have to verify anything. And so, also 9, 9.